Alright, so what I wanted to do today, and in the Google Classroom you could see that I called it the Cilio worksheet. He came up with this, I'm giving him credit for it. What we're going to do is we're just going to, in person or virtually or whatever you want to call what we're doing right now, we'll do the evens on here, and then for homework I'll ask you to do the odds. Alright, so what I'm going to do first is let's start with day 1. Today is the 8th. And we're just going to be reviewing section 5.5, half angle review. Okay, and in a previous lesson I had told you I'll let you know for a half angle if this is an acceptable answer. And Mr. Cilio said it is for him. So just kind of going forward, it's okay if you leave your answers like that in the homework. I'll accept that. Usually what I would make you guys do is I would make you rationalize it, which is what we've been doing all year, but I just want to make sure that I'm consistent with Mr. Cilio. So if he says, you know, it's good for him, he's been doing this longer than me, so I'll respect what he does. All right, so just so you know, this will be acceptable. This is the best answer, like mathematically going forward for the rest of your life, but we'll be okay with this too. All right, so let's take a look at this worksheet. I told you that I wanted to do the evens with you. All right, so number 2, it says find the cosine of 112.5, and that is in quadrant 2, where sine's positive. So the answer is going to be a negative, and we're going to be using the cosine of 245, I believe is what this is. So let's see here, 112.5 times 2 is 225. Okay. All right, so remember what we said. The answer's got to be negative because we're in the second quadrant, and it's going to be the square root of 1 plus the cosine of 225. So 225 puts us over here. 45 degrees, -1 over root 2. So the cosine would be negative root 2 over 2. And we're going to be dividing by 2. So cleaning this up, it would be negative, let's see here, we can multiply top and bottom actually by 2. We would get negative square root of 2 minus root 2 all over square root of 4, which is just 2. So that would be the answer. Taking a look at number 4, number 4 is asking us to find the tangent of 112.5, which again is in the second quadrant. So we're going to be using the tangent of 225 divided by 2. Well, I'm going to use this formula, 1 minus the cosine of 225 divided by the sine of 225. This would be 1 minus negative root 2 over 2 divided by the sine, which is negative root 2 over 2. So using algebra, this is really just, let's see here. The top would be 2 plus root 2 over 2. We're going to be multiplying by the reciprocal of 2 over negative root 2. These cancel. And if we multiply by the conjugate of root 2 over 2, we get, that's going to be square root of 4, and then 2 root 2, all over negative 2, which reduces to just be negative 1 minus root 2. That would be the answer for number 4. Number 6. And number 6, it says the cosine of 67.5. Well, that's in quadrant 1. So our answer for the cosine of 135 over 2 is definitely going to be a positive square root. And of 135, puts us over here. That's negative 1, 1 over 2. We would have, let's see here, it's going to be 1 plus the cosine divided by 2. And we're going to be multiplying by 2 over 2 to rationalize. So we get the square root, let me see here, the top would be square root of 2 minus root 2 all over the square root of 4. That would be what the answer is. Okay. Taking a look at number 8. Number 8, it's asking you to find the cosine of theta over 2. If cosine of theta is in quadrant 2, and we know the cosine is negative 5 over 13. Okay, so if that's where theta is, this angle is theta. So we're asking to find, let's see here. So if the cosine, let's see, it always takes a little while. Cosine is definitely negative, right? So if that's going to be the angle, cosine of theta over 2 is going to be in quadrant 1. If we take this angle, whatever cosine of theta is, say it's 100 degrees, and we divide it by 2, it gives us an angle in quadrant 1. So cosine of theta over 2 is in quadrant 1, which gives us a positive square root of 1 plus the cosine divided by 2. And if we multiply, let's see here, this one's going to be a little bit trickier. I'm going to actually figure this out here. So 1 plus negative 5 over 13 divided by 2 gives me a positive square root of 4 over 13. And we have to multiply by root 13 over itself. The square root of 4 is 2 root 13 over 13. Okay. And number 10. Number 10, it's asking us kind of the same thing. We are in quadrant 3. It's saying this angle is theta. And it's saying that sine is negative 15 over 17. So let's see what the other side is. Be negative 8. So if that's theta, number 10, it's asking us to find sine of theta over 2. So sine of theta over 2, okay. Well, if that's theta, say that's 200 degrees, right? Half of that would be 100, which puts us in quadrant 2. In quadrant 2, sine is positive. So this is definitely a positive answer. And we're going to be finding the square root of 1 minus the cosine over 2. So let's figure out what that is. 1 plus 8 over 17 divided by 2 is the square root of 25 over 34, which we know we take the square to the top and bottom. And to rationalize, we multiply by root 34 over itself, giving us 5 root 34 over 34. That would be the answer for number 10. Okay, moving on here, number 12. 12, it's asking us to take the same thing and find the tangent of theta over 2. Well, if theta terminates in quadrant 3, an angle would be like 200. Half of that would be 100. So we're definitely in quadrant 2. That would give us a negative tangent. And for number 12, let's see, we could use any formula. I'm just going to use this one. It's 1 minus the cosine of x, cosine of theta over the sine of theta. I'm looking at my triangles. It's going to be 1 minus the cosine over the sine. So let's see what that is. All right, calculator time here. 1 plus 8 over 17 divided by 15 over 17. Calculator's telling me it is negative 5/3. All right, that was number 12. All right, so now let's take a look at the other side here. All right, so it's asking us for numbers 1 to 4, find the exact values of sine, cosine, and tangent. Okay, so for number 2, on the back, it's telling us that cosine of u is 7 over 25, and we are in quadrant 1. Cosine is 7 over 25. Which means that this missing piece is 24. All right, so we have to find sine of, we're calling it u here. Cosine and tangent. All of them are going to be positive. So let's see if we can figure this out. Sine would be 1 minus the cosine over 2. Cosine would be 1 plus the cosine over 2. And tangent, doesn't matter which formula we use. I'm going to use 1 minus the cosine divided by the sine. Okay, this one's probably going to be the easiest to find. I'll just get that first. 1 minus 7 over 25 divided by 24 over 25. And that gives me 3/4. Okay, for these other ones, if we multiply by, yeah, it's a little tricky. I want to try to get a perfect root in the bottom. Mr. Celia would be okay with this, that's what he told me, but I am just going to do the right thing and find out what makes the bottom a perfect radical. So we could do this a couple different ways. I know if I multiply by 100, or if I try to make, if I multiply by 50, that would get rid of fractions, and we would get the square root of 50 minus, let's see, that's 25 goes into 50 twice, minus 14 all over the square root of 100, which gives us 50 minus 14 is 36 over 10, which is 6 over 10, or 3 over 5. Okay. We could have also just simplified this, and I'm sure that would have been fine, but you know, just another way to do it. And for this one, what I'm going to do is I'm going to actually do the square root. Instead of dividing by 2, I'll multiply everything on top by 1/2. So let's see here. 1/2 plus 7 over 50 is 16 over 25, which is 4/5. All right, so that's pretty easy. And you can see there's a few different ways we could do that. All right, so 2 more to go. Number 4, it's asking us if cotangent of u is 7, and u terminates in the 3rd quadrant, and the cotangent is 7. So that's 7, this is 1, they're both negative. This is u. So 1 squared plus 7 squared is square root of 50, which is, that's the hypotenuse, which is square root of 2 times square root of 25, 5√2. So we have to figure out the other ones here, so let's do that. Okay, so the sine of u over 2, that would put us, let's see, if this is in the third quadrant, if we're in the third quadrant and we're trying to find u over 2, so let's say angle u is like 200 degrees. Half of that would be 100, which puts us in quadrant 2. The only thing that's positive there is sine. And then tangent, we just kind of figure out when we get there using one of the formulas. All right, so I'm actually going to use for the tangent formula, I'll use 1 minus the cosine over the sine. That'll be fun. And let's do these other pieces too. So sine of u over 2, that's going to be 1 minus the cosine. And let's actually just do it over here. The cosine of u would be negative 7 over 5 root 2. Multiplying by root 2 over itself, we get negative 7 root 2 over, if you multiply top and bottom by root 2 over root 2, 5 times 2 is 10. That's what the cosine of u is. And the sine of u would be negative 1 over 5 root 2. If you multiply top and bottom by root 2 over itself, you get negative root 2 over 5 times 2 is 10. So I'm going to actually use that to reduce the amount of work I have to do here. So actually I'll replace that with tangent. So if it's going to be 1 minus the cosine, and over sine, we multiply top and bottom by 10. And then multiply top and bottom by root 2 over itself. We would get 10 root 2 plus 7 root 4 over negative 2, which gives us an answer for tangent of, let's see here, negative 7 minus 5 root 2. That's what that would be. Let's do these other ones here too. So all right, let's see what this comes out to. If we multiply the top and bottom by 50, we would get a perfect radical in the denominator. And we would get 50 plus 35 root 2 all over the square root of 100. So that would be a rationalized answer. You should be able to go from here to here. Okay. What I did is I tried to figure out a perfect radical to make the bottom, and I also tried to figure out what would also get rid of that. Another way you could do that if you're having trouble is just multiply the top by 1 over 2 instead of dividing by 2. This would give us a negative square root of 1/2 minus 7 root 2 over 20. So let's combine fractions. I'm going to multiply the left by 10 over 10. This would be 10 minus 7 root 2 all over 20. And we want to try to get a perfect radical in the denominator, so we can multiply top and bottom by 5, giving us the square root of 50 minus 35 root 2 over the square root of 100. So you can see it's a similar answer to the one that we got before. All right, one more problem. Let's do number 6 on the Mr. Cilia worksheet. And it's the cosine of x over 2 minus the sine of x is equal to 100. We want to solve this on the interval from 0 to 2 pi. All right, so I know the formula for the cosine is plus or minus the square root of 1 plus the cosine of x over 2. If I bring the sine on the other side, Now I'm going to have to square both. I get 1 plus the cosine of x over 2 is equal to, well, eventually we're going to have to get cosine. So if sine squared plus cosine squared is 1, that means that sine squared is 1 minus cosine squared. And let's finish this up. Multiply both sides by 2. And bring all these on the other side. So we could factor this. Almost done. This would be 2 cosine of x. This would be cosine of x. 1 and 1. We have to get positive in the middle. We would need a positive 2 here and a negative 1. What angles would give us 2 cosine of x minus 1 equal to 0? Or when is cosine equal to 1/2? We've seen this a few times. That happens at 60 degrees and at 300. Uh, 300 would be 5 pi over 3. And then when is cosine of x plus 1 equals 0? Or when is cosine of x negative 1? That happens right here when x is pi radians, or 180 degrees. All right, so for homework, what I would like you to do are the odds on this worksheet. Thank you very much. Have a nice day.